I think I got it. Does it say that it started recording for you guys? Yeah, okay, I see Kevin. Thank you. Sweet. Okay. Alrighty, well, hello everyone that's on YouTube watching this right now. Also hello to everyone that's in person and on Zoom. This is part of our BOPO AMS speaker series. This is our second talk of the series, our third event. But we are excited to have Ryan May, who works at Unidata, which is a part of UCAR, the University Corporation for Atmospheric Research. He is a software engineer and is an alumnus from Oklahoma. So I know Kevin, I'm pretty sure is friends with Ryan, so they know each other from that. But I'm going to go ahead and I'll pass it off to Ryan because I'm sure he can give himself a better intro than I can. So, but yeah, excited to have you here, and thank you, Ryan, for coming.
I appreciate y'all having me tonight. Let's see if I can figure out how to share my screen here. Oh, there it is in Zoom. Host disabled participant screen sharing.
Yes,
so.
let me work on that. I'm getting my understanding what the professors go through. So here, let me stop my screen, and I can see if I can.
You think you go to share screen, click the arrow maybe?
Good call, good call. Multiple share. Advanced sharing options. There we go. Okay. I think you should be good now. Give it a try. If not, I can try something else.
It's asking, and then of course that means on my Mac, I will likely have to quit and rejoin because of course technology can't be easy. Yep, I'll be right back.
Okay, no worries. Short intermission here. Anna, how was your day?
You know, not too bad. I dropped my brother off at school at 6 in the morning. Well, no, it was 6:30. So I'm awake.
Very nice, very nice. All right, it looks like Ryan's back. You can see if it works now. There you go.
And what are you all seeing right now?
Right now it just says, oh, okay.
Making a program.
Yep.
Okay. So, yeah, when I was asked to give this one, I sat there thinking about what I was going to present on and decided to reflect a bit on the, I don't know if I say strange journey, but it's been a journey getting to where I am. And I thought I'd just present some of that, and then I'd be happy to take questions during or, you know, when we get to the end. Either way works. But yeah, and also just kind of hopefully give you all some insight into going down the route of, you know, programming and so, we'll say software engineering, but I still don't consider myself much of an engineer. But yeah, and hopefully dispel some of the mythos around programmers and being a real programmer and things like that. So, and if you can't tell already, I don't take myself too seriously. And so, you know, the theme of tonight is if I can be a programmer, you can too. So I want to get my other window up here and then get going. There we go. Okay, so who I am, I'm a software engineer at Unidata. So the day job, what that is right now is I get to be the lead developer of the MetPy project. And so that involves all things MetPy. I also do a lot of teaching Python. I think I did teach at least one workshop up at Valpo. And then I have a personal hatred for all of our meteorological data formats because they are a cause of no end of grief in my day-to-day existence. And so, yeah, that's as opposed to, you know, being a Capricorn and liking long walks on the beach, I just hate data formats. So the brief spiel on Unidata before I delve into, you know, who am I and what's my background. So Unidata, where I work, we've been funded by the National Science Foundation for over 30 years. And that mission is to provide access to real-time Earth system science data. And then we do a lot to help support the use of this data, either help answer questions, help provide resources, and then we also work on a bunch of tools to help work with this data. That's the full end-to-end suite of things you might want to do with data. That can be distributing it using the LDM, putting it up on a server so you can access it with threads. How we store data, we work on a library called NetCDF that makes it a lot easier to access data and work with it. And then there's a variety of tools we work with in terms of desktop applications so that you can look at all this data. That could be the Integrated Data Viewer, IDV, or we're also responsible for repackaging AWIPs into a form that's useful for putting on classroom machines or running on your laptop and things like that. And of course, near and dear to my heart is MetPy and the other set of Python libraries like Siphon that we work on to help bring the Python suite of tools and make it useful for you all to use in your day-to-day meteorological existence. And so our primary community that we're supporting in this is the university community. So Unidata exists to help you all and to make your lives easier. That is our mission, and that's what I love about this place. We also do get to work a lot with governments and international users in the private sector, but our primary core mission is to serve the universities. And so I just wanted to give my little elevator pitch here for Unidata. And with that, we can get into the log cabin I grew up in long time ago. So a software engineer, what does that mean exactly? Well, it means a lot of challenges. And so a couple of things that really help frame the problem here is that, despite what you might want a computer to do, it's going to do exactly what you told it to do. No more and no less. And so, it's a lifetime of challenges trying to figure that out and say, okay, no, I meant you to do this. Don't do what I told you, do what I meant. The other thing that working in the meteorology sector has meant is it's a lifetime of challenges with just this phrase, meteorological data. Because, from METAR reports to buffer to GRIB to random things that the Weather Service sends out over their feeds, just our data formats are an unending source of challenge. I should be happy about this because it provides job security, but there are days that remark on a regular basis how I just want something to work, or I turn one little problem, oh, this should be an easy afternoon hack just to make this bit of data work, and you just keep uncovering new little fun problem to solve after fun little problem. So that's kind of what the job is meant. And then this I happened to see on Twitter just today, which I think just sums it up perfectly. So with that, how did I get started? So I'm a dinosaur at this point, and part of making this talk has been coming to grips with that fact. So this is literally the first computer I ever got to use. All 8 megahertz of it. IBM, I forget what model, but ancient computer. I think I had all of a 20 meg hard disk, which means my cell phone would take about 4 pictures and filled up the entire hard disk of this computer. But that's where I got to start as like a 7-year-old playing with games that, if you were lucky, had 4 colors on the screen at a time. A lot of them were also just text-based, but getting to play with that as a kid, that was always fascinating and fun, and that gripped me really, really hard. This was also the days of, DOS, which meant no Windows, no point and click. We eventually got there in this computer, but I think what's kind of funny about this is using DOS actually prepared me well for working now with Linux or working at the Mac terminal and actually continuing to work from the command line. But there was this interesting arc of you had DOS, then everyone wanted these point and click interfaces like Windows and things like that. And not that those don't make certain things easier, but on my day-to-day, I'm still working at the command line to do a lot of the things, things like Git and things like that I want to work on. So just that's where I started, and in a lot of ways, I'm still there today. And then the programming bug hit. And I think it started, I had some friends in school. We got the computer lab, I forget whatever we were doing that day, but we got to experiment with BASIC and play with it in the classroom. And then I had a friend who, of course, was more advanced and could do all these cool things that I wanted to learn, and found out that my dad programmed at work sometimes, and so begged him to show me things, and that kind of kept going. And then one of the things back in the day, this is pre-internet era, so it wasn't just go hop on Stack Overflow and figure out what snippet of code you wanted to do or have any resources at all. We had these things called libraries that we went to. And one of the things I could do then was check out a book that had basic games in it. And you could get the book, open the page, and there's a whole listing, as I have a sample here, of just line by line of code. And I'd spend an hour typing in line by line the entire program, and then get the payoff of running this game. And I still don't know how that managed to hold my attention that well, but it did, because it worked. And you'd make mistakes typing it in. First time you get to run that, just like normal programming, you got to run your code for the first time, and it's not going to work. You sit there, as a 10-year-old wondering what the heck's going on here and why isn't this working, but get through it. And I don't know, something about controlling what the computer was doing and being able to tell it what to do and modify the program, and have that creative side, which I don't often think of myself as a creative person. I don't like drawing. I don't, coming up with music, all those creative arts, I don't associate with my natural predilections. But programming in that way is kind of a creative thing where you have this idea in your head and you're making it appear. You're bringing to life some creation from your head. Just for me, it's making some logic machine do what I want it to do rather than flowy lines or sweet music. So from there, periodically crashing the family computer and having to reinstall it from scratch, and learning to do that on my own so I don't have to go tell my parents that I leveled the computer. I eventually got to the point where I made my own hurricane tracker in there, because I did have the meteorology bug a bit there. And, what'd you do in the summer all summer? Well, you're waiting for the Weather Channel to come on 50 minutes after the hour and get the tropical update to get the latest location of, hurricane, whatever at that point. And, oh, I could write a program to do this. Again, this is still pre-internet. So this isn't like going to the National Hurricane Center and getting your updates. This is waiting for the TV and scribbling them down and plotting the points on a map by hand. And that hurricane tracker, man, that started with somewhere I encountered some drawing program that lets you save whatever you drew as a basic object file. So this wasn't using graphics. This was a text-based thing that I could do. But figured that out and hand drew a map of the United States. And this was not art. I've already established I cannot draw. But I hand drew this map of the United States so I could have something to do with my hurricane tracking program. And, it was more about the journey and having this thing that I wanted to exist, and figuring out all the problems that really was what it was. So from there, I was always interested in storms. I love thunderstorms. I remember growing up and having, just memories of nothing super severe, but, thunder, lightning. I grew up in Maryland, so we didn't have, the plains level of storms here, but that was fascinating. Natural disasters are always fascinating, just the forces of nature. It's really cool. I mean, today I have my window open and it's 46 degrees outside, but I heard people saying they could hear thunder outside. So of course my window's open just so I could try and get a sample of thunder, because Colorado Front Range is very hit or miss around here. So as I'm, going through high school and figuring out, okay, what am I going to do with my life? Oh, meteorology, that's something I can do. That's a job. I could study this as a scientist. Well, that sounds really cool. So it was, it's kind of a deviation from being a prototypical computer nerd and everything. I mean, obviously only so much because I made a hurricane tracker here, but meteorology grabbed my attention. And having played around enough over my career, meteorology has always been the binding force. I don't necessarily, we'll get to more of this as I go through, but forecasting, all these other things aren't necessarily what I want to do, but doing computer stuff that isn't meteorology is always been of much less interest than doing it with meteorology. So that intersection of the two pieces has been really important and really productive in my life. Okay, so meteorology. Well, of course I'm gonna go to Oklahoma. No, not of course. I grew up in Kentucky, Maryland and then Kentucky, so Oklahoma wasn't the obvious one, but Oklahoma is famous for severe weather, and my family was already moving to Kansas after I graduated high school, so the Plains was a natural location to look for college, and Oklahoma happened to be a pretty good choice for that. And my memory is trying to think back to undergrad, the things that I took away, Oklahoma, okay, the chasing culture that was just prevalent to a fault, we'll say. I remember undergrad doing lots of physics. If it wasn't actual physics classes, then it was doing dynamics, thermodynamics, whatever. Every class I did in those days seemed to begin with, we're just doing applied physics, going through equations, symbol manipulation, whatever. And then I remember the forecast contests. Always doing that. We had the local forecast contest. At that point, it was the national. Before the weather challenge, it was a national forecast contest. And being the competitive person that I was, a competition, sure, I'll do that. So those are the things I remember taking away early in Oklahoma. And I also remember, driving around, chasing. Well, I don't like to be idle. I don't like to not be doing things. Sitting in the middle of nowhere in Oklahoma, Texas, Kansas, and, just sitting there didn't really jive with me. So the chasing thing wasn't my strong suit. Really wanted that instant payoff. So it just didn't make me a very good chaser, nor did that make me a good candidate to go do field work or any of those kinds of things where you're just sitting and waiting. So the forecast contests. In hindsight, really, it was an excuse to screw around with computers some more. At that point, it was make your own departmental website and put up your Genpack generated graphics and just populate whatever maps you wanted to make your forecasts. And, I did the contest as a excuse to change my maps and figure out what maps I should be making for it. But the computing was more interesting. I mean, I think I remember writing some kind of script for a web page, but because I didn't know much, I wrote in Fortran. So just the irony of a Fortran powered element on a website, because I think we were using the weather program to get out like the daily high and low temperatures. And of course, METARs, you have the two temperature groups, and we're talking forecasts and error points. Well, I needed to know the most accurate temperature observation for the day, so I knew how much error I had accumulated. So I had, written something in Fortran to go pull out, make up for some failing in this program. And yeah, again, solving technology problems. And the competition on the forecast. But the meteorology, I wasn't forecasting. I was, at best human moss, just trying to shave a temperature degree here or there to gain points and stuff. And that all came to a head one day. I was leading, I think, a forecast for Barrow, Alaska. And I'm in first place, and I'm feeling also good about my abilities there. And then see something about the dew point observation. Oh, I don't think we're going to get that cold that night. Yeah, well, I was wrong, and busted by about 21 points. Forecast for Barrow. And got my pride wounded a bit there. Could never recover, could never get back to first place. And that just kind of eased my way out of the forecasting business, because my instincts for the weather were just never that great. But the computing side and putting all the tools together for those things, those were always fun. So yeah, that was how I felt after Barrow, Alaska. So figuring it out as an undergrad, I was a terrible forecaster, still am. Don't like chasing and seeing nothing. And what I really liked is I still liked doing the computing side of things. And then I discovered some things, discovered radar while working in school. That was one of the data sets we got, and it was always fascinating, probably because it was severe weather related. It was the thing that updated the most quickly, right? You always get radar updates every 5 minutes, and so you can see what's really going on in the atmosphere in real time. Back then, satellite imagery was coming in maybe every hour, if that. And so, radar was the way to get the information quickly, and again, the high resolutions and looking at tornadoes and things like that. So, luckily, one of the things being in Oklahoma is there's quite a few of the federal organizations there at that time, and they had a student job at the Radar Operations Center. So I got to apply for that and got it. And I think that really helped the journey keep going. So at the Rock, you get there as a student, and what's your first exciting job? I spent hours upon hours manually looking at imagery of radar data, just velocity field after velocity field, and scoring the quality of what an algorithm was putting out. In hindsight, wasn't glamorous, but man, I was sure excited when I started my first real job in college, working in the field. It was a nice change, and it helped open the doors to a lot of things. And as I think now, it's like this is literally probably the 20 years since that job happened. So this has been a nice reflection on 20 years in the business. And after doing some of that velocity image scoring and all that, at some point, someone basically handed me Teach Yourself C in 28 days or something, and helped. You just said, turn me loose on that, and start going through it and start learning it. And so, I'm getting paid to learn C and program. Well, that was kind of cool. And then from there, I got to do things like they're having different releases of the software for the radars. So we needed to compare the products between the two releases and make sure everything that did change was expected, and things that shouldn't have changed didn't change. So I got to create from scratch this tool in C to work with these things. That was cool. And by the time I left, we've been working the MPDA algorithms, what I was scoring things on. So I spent my entire life at the Rock working with this MPDA algorithm. That's the multi-PRF D-Alice algorithm. And so I think that was VCP 2121. I forget what they've changed it to now. They are still using it in different forms, basically dealing with the purple haze on the radar data and trying to lessen that. But by the time I left there, we were actually, I and my mentor there were working on integrating that into the operational system and optimizing the code to help it run faster. Because I think when we first got it, it was taking like an entire minute to do a scan. By the time we got done with it, it was like 10 seconds or something. So really cool, just getting in the nitty gritty and seeing all that, this is a far step from the days of BASIC and my webpage and Genpack. This is now like, this felt like the real deal. And so that was cool, intoxicating in some ways for me at that time. And so, go through the Rock, and then graduation hits, and what are we going to do? Oh, missed this one. Yeah. So undergrad projects, in addition to working at the Rock, I kind of spent most of my undergrad figuring out ways to just screw around with computers some more. So like I said, did the Genpack graphics. I wrote some Perl, some god-awful ugly Perl code that powered this, basically the precursor to RadarScope. Back then, the Oklahoma Mesonet had a plugin that you could run in your browser that would display this stuff called WXML, the weather markup language. And so they were using it to power the OK First site for emergency managers, but the plugin would work for other things. So I figured out how to write Perl to generate this. I think the main thing was I wanted storm attributes like tornado detections on top of other products rather than, I think it was only available on the composite reflectivity or something. And so figuring that out, or trying to make sure I could, or get to overlay reflectivity and velocity, things like that. Again, I wanted something to exist, and oh, look, here's another one, Perl. I'll dabble with that. Also, while doing that, I nuked that code for that plugin and had to go very nicely to our system admin and say, hey, do you have any backups of my home directory? He didn't have a super current copy. I think I lost an afternoon of work, but at least it wasn't like all of it gone. So one nugget of advice here, make friends with your sysadmin. It's good to have them on your side and have them willing to go search backups for you and bail your butt out of the fire. So yeah, a lot of just whatever I could, what was either radar or computing related or both. That was my life in undergrad and onward. So from there to undergrad, going to grad school, and hey, this is the real world now. We're professionals. You figured it out. It was just school, but I had an office in the building. That was grad school. But it was a good place to continue to learn. I got to apply my skills more, had a research project. Well, I also had a coffee pot. My office was the place with the community coffee pot. So many hours. I won't say lost. At times it probably felt like loss. We spent a lot of time chatting about things, raving about politics or other stuff, but there was also a lot of discussions about software and how to do it right, and how crappy scientific software is. And there were days where Fred Sean or Kevin would come into my office at one point in the day and then leave, and then Mark, our sysadmin, would come in after that and then leave, and then my advisor would show up at 2 p.m, and we wouldn't talk about research, we'd talk about other stuff. And so there were entire days, and many of them, that went through in grad school where it was not a productive, like, just when you think, I'm going to get into this, and it's as much as everyone else's is my own, I could go work on research, or I could go play with this computing thing. At the same time, as I reflect back, those conversations and having that has just been as important to my career as the formal research work or classroom work, because all those people I spent all those hours chatting with are, my professional network, as it were. Working with Kevin now, I got hired at Unidata because of my professional network, or at least I got notified of the job. And also it really helped inform my thinking on working with software and how my passion for it and how I wanted to do it right. Grad school is also 6 years being my own sysadmin on my research box, which was kind of cool. Run this Linux distribution called Gentoo, which meant you were building everything from source, every package, which sounds kind of cool. You're optimizing netcdf so it runs the fastest possible on your computer. It also means you're compiling things like OpenOffice, Firefox, your entire operating system kernel from scratch. A lot of hours lost to that. A lot of hours lost to figure out how to get the Adobe Acrobat Reader to actually properly open PDFs in my browser, recompiling my video drivers, trying to make things just as videos play, because you needed a certain plugin to things. So a lot more screwing around computers. I learned a lot about how Unix systems operate. You spend a day compiling your kernel, or forget to compile certain things in your kernel and wonder why it can't find your hard disk. You learn some things, and it was low pressure messing up. I made a lot of mistakes getting the system set up, but I also learned a lot about how Linux works and how computers really operate, and that also productive messing around, we'll say. So the more formal part of grad school, I got to this research project that was simulate radar data from some high resolution model output. And we were doing that to study how radars see tornadoes from distances and with certain configurations of the radar. So I got to start my own more or less radar model from scratch, which was really cool, and get to start that out. And you think you're going to try and do things right, and you run into your own limitations, and years later it's like, why did I do that? Another great learning experience, just being able to play with something on my own. And I got to live with that project for 10 years, and we'll get to that time span more going forward. But with that, it was interesting. That was the CASA project in Oklahoma was driving that work. And one of my earliest grad school memories, I had early results from the simulator, and it was cool, and it was working right and showing how, 3 kilometers away from a tornado, you can see these, really high resolution tornado. But going out to 30 kilometers, there's no tornado to see there, not with a 2-degree beam radar. And so getting up in front of an entire large research project and telling the PIs that their vision of seeing tornadoes at large distances was a pipe dream was an interesting experience as an early master's student, but a good one. And we weren't stretching it. It was what our data showed, but it was not a popular opinion. So I had this tool that I was trying to, it's generating radar data, and I needed to display my radar data. And so I have these files I had made, and I'm trying to I want to get that payoff. I had the tool. I want to see how it's working. I want to see the images. So I tried literally every existing tool we had there. That would have been Widzy. That would have been Unidata's own integrated data viewer. This would be years before I came to Unidata. This was the radar editor of choice there in the research community, Solo. I tried everything I could get my hands on and could not get my data into that. Now, how many hours did I spend? I spent a good solid week trying that, and then said, you know what? The hell with it. I'm going to write my own. And, you know, hubris is a powerful thing. And being maybe not arrogant, but enough to not question my abilities to actually do this on my own. And so what did I proceed to do? I proceeded to teach myself C++, GUI programming, and a bit of 3D graphics. And after, you know, I don't know what kind of time frame that took to get that far, but I eventually got there where I had my own graphical program that was displaying my research data and making the pictures I needed, and actually managed to do that, the presentation for that, for the CASA group I mentioned before, and managed to make all my master's publications with that. And I was quite proud of that. I'm also kind of sad I can't run that anymore. It doesn't compile. You know, the world has moved on in 15 years. But that was a great learning experience, just teaching myself those tools, and, you know, the power the internet gives us of being able to just Google for a few things and find vast amounts of resources to help teach, you know, pick a technology stack. And, you know, maybe the science resources for like meteorology, the basics of science, maybe questionable on the internet, aren't as good depending on who you find. But man, programming resources on the internet are bountiful. And so I'm not going to say you can learn everything on the internet, but man, programming, there's no shortage of things you can find on there. So go through that, get my master's, come to the end of that journey. You know, I don't think I'm ready to leave school yet. My protective cocoon here of being in school. Well, sure, they're willing to let me stick around for a PhD. I'll do that. Why not? This is a terrible reason to get a PhD. I just absolutely god awful. I mean, it was cool to go down to technology. I was fascinated by radar, so I got to go down. I'm not sure why that got cut off. Whoop. That should be and engineering. So I was trying to go down this route of radar meteorology and radar engineering, and studying signal processing and really learning how radars actually worked. Because I think up to that point, only had a useful meteorological knowledge of radars, but there's a lot more going on when you're working with the individual voltages coming down from things, and the electromagnetic physics that are going on when radar, when electromagnetic waves interact with raindrops and hailstones and things like that. Fascinating things I was, you know, academically interested in. But I didn't go into a PhD with a goal of like, that was going to help me get to some stage in my career. I didn't say, oh, I want to do X, and therefore a PhD is something I need to get there. And in hindsight, I think that probably, it would be good to do some more reflection and say, what am I going to do with this PhD? So then PhD life, and with going into the engineering route came MATLAB, which opened up a whole different realm of things, which is really cool. I'm not a MATLAB proponent now, but at that time, that was the first real interactive computing environment I'd gotten my hands on. Everything else was you write some C code or you write some Fortran in a file, you compile it, you run it. If you're lucky, you figured out how to get some kind of plots or whatever else out of this code, but it was, you know, this big loop in terms of trying to make changes and see what happens. Whereas MATLAB, getting plots was easy, you know, kind of unified, kind of bridge between Excel, where you can make plots easily out of some columnar data, and programming, where you could write more complicated things than you could in Excel. And you had just had this environment where you could quickly type code, work with matrices, load up some radar data, and do the signal processing on it. So it was really cool to me at that time. But that first class I took in, it was Doppler weather radar signal processing, an engineering class. And we got in there, and it's the first time I'm encountering engineering looks at signals and systems. So signal processing. My partial differential equations class talked about Fourier series, but never actually got to Fourier transforms, which on the engineering side of things, 90% of signal processing somehow involves Fourier transforms. So I didn't have that background to fall on. And I'm using MATLAB for the first time, which is a programming environment I don't know. And man, my head has never spun so much in my life in school, just because I didn't have a comfort with the source material like you would have in meteorology when you're plotting. Okay, you know what the meteorology is supposed to look like, so the coding you can keep inching towards making reasonable meteorological maps. Or if you know the coding, you can then work with the code to make decent plots that unveil the meteorology and help your knowledge there. But man, if you have nothing to fall back on, I have never spent so much time in office hours in my life. Like, okay, why is this code not working? Why does this plot look weird? What's going on? And I'm just going through this thinking I'm going to bomb this class, and oh God. And in the end, everything was fine. And once we got out of the early stages of this and got to like the applied part of radar and trying to interpret pictures of things, you know, everything was fine. And being like the lone meteorologist in that class, it was useful to have a certain perspective on things. I'll never forget the first time the professor who knew enough meteorology, who was an engineering faculty, but had done a lot with meteorology, drew on the board several shapes and asked the class, you know, like 9 people, you know, which is used as a shape of a raindrop while it's falling. And, you know, everybody else expects this teardrop shape, which is not at all how raindrops look when they're falling. They look like hamburger buns. And so it was just interesting, you know, despite feeling so lost, you know, I'm sure everyone else felt lost when we got to the actual meteorology and trying to interpret what velocity data looked like, you know, on a normal radar image versus what they're used to looking at, which is more or less, you know, versions of sine waves of these noisy looking, you know, line curves, more or less. So that was cool. But that was definitely a struggle for a while there. But that actually, it didn't scare me off, and I kept going down the engineering route, and definitely led to me going deeper in the radar world. So then, spring 2006, trying to publish my master's research, getting everything in line, checking out all the last images and research stuff. And I'm just trying to sanity check my little simulator and make sure everything works. I've been using MATLAB for a time, and I don't know why this occurred to me. I don't have enough computing challenges in my life. So debugging my code, you know, I'd heard enough of these articles about Python as a sort of MATLAB-like thing that was free, and, you know, dealing with on a regular basis, trying to get a hold of the MATLAB license server and trying to work from home and things. It was like, let's try out Python. Why not? Well, in an afternoon, I was able to dump some things from my research code and, you know, quickly get them plotted up in Python. And one, the speed with which I was able to do the MATLAB-like things, but from a free language, a free tool, was kind of cool. I also uncovered several bugs in my research code that was good to get squared away before publishing that journal article. But at that point, I was hooked on Python. That was like, oh, I can see the value here of something that's like MATLAB, but free, and it has, you know, an astronomy community behind it and a lot of, you know, other people on the internet working on this tool. And that was kind of cool. So summer of 2006, I was planning on spending that summer studying for my PhD qualifying exam. Now, whether or not I need to spend an entire summer prepping for PhD quals is a whole other thing. But I chose that summer to learn Python from scratch instead. So instead of just hacking together things, I was like, okay, we're going to learn this for real. I spent all summer reading everything I could on Python and going through books. Odd decision to make while preparing for quals, but in the end, time well spent. I mean, Oklahoma doesn't even have a qualifying exam of that kind anymore, and that's good. And the time spent learning Python has definitely paid off in my career much, much more. And in so many ways, the Python has paid off. Python really helped introduce me to the open source science community. And that includes, I went to the SciPy conference for the first time, I think in 2007 or something. And that helped, help me make connections with all sorts of people who work in Python, and help open my eyes to a lot of best practice working with scientific software and writing it and creating it, and doing testing, and trying to make sure things are documented. And eventually in the Python world, this thing called continuous integration, which just means writing your tests automatically every time you do something, so that you know when you break stuff. But so much scientific code out there doesn't have tests and isn't maintainable. And there was a community of people that really wanted to do things the right way. And it hadn't occurred to me so much that I can go learn what the right ways are, and that there are people trying to do this, and that there are people I can ask questions of to learn what the right way was, or the best way, or however you want to phrase it. And so that was a sea change. And so that paved the way for more. And so from there, Python use grew. You've seen the curve in your all's classes, doing more and more Python. This was the start of it. And it took off within our department, as all of us graduate students would talk and say, hey, look at all the cool pictures we can make, and how easy it is to use, and the code doesn't look terrible like Fortran, and this and that. And so it's like, oh, there could be a meteorology package that we had that, would be great. And that was the origins of MetPy, 2008. I'd like to say it just took off from there, but as it does, life happens, and people graduate, and people go on to faculty jobs and real jobs, and things that don't, necessarily help you code. And so, but the idea started then, and we glued together a bunch of grad school code and things we'd had. I don't know that much of it lives on. I think bits and pieces do, but it was the start. That was the genesis of MetPy. Also around that time, I think existential crisis is probably about right, because I'm looking around and seeing, what does my advisor do, and what do other faculty do? Well, they write proposals, and they write papers, they supervise the grad students, they teach, they go to meetings. Especially with regards to me, you can notice a certain lack of something there, and that's coding. Don't see my advisor coding. Don't see my advisor hand doing a lot of research. He's definitely, help sitting with the grad students and analyzing and going over conclusions and stuff, but getting the hands dirty and not programming. And that was kind of like, okay, that makes me sad. That's where I'm at my best, is getting my hands dirty and solving problems, and not these other things. And the idea at that point of like guiding my own research program, writing the proposals, and figuring out what science I wanted to study, what problems, was terrifying. And so I'm like, I'm not sure this is, faculty routes not really what I want to go with. And, look around also, even the PhD level jobs in the labs are kind of like, oh, I'm not sure I'm going to do exactly what I want to do. What I like doing now is not what I'm going to get to do. So it's kind of like that part where I said I didn't have a plan for what I was using my PhD for. This is where that kind of reared its ugly head. So I kind of felt like this poor little robot here, saying, what is my purpose? And, oh God, what have I done to myself here? And so it just so happened at that time, Enterprise Electronics Corporation, which is a radar company, and they had just sold OU their own radar, and were trying to start an office in Norman to kind of help the university work with radar and try and promote this partnership. They opened a job that was in radar, obviously working with their radar software, and involved this technology of Qt and OpenGL, which were exactly the things I had taught myself for that program I wrote to visualize my data. It wasn't Python, but man, it involved some things I knew pretty well and had worked with. And so I applied, went down there, not even talking about my radar expertise, just purely on like, I'm a programmer who knows these things. And it just happened to come up during the interview, and they were shocked that I didn't mention. It's like, well, the job didn't say radar. It said Qt and OpenGL. That's what you were looking for. So I interviewed there, and, I decided that I'd start part-time working for them while I finished my PhD in 2009. Yeah, well, more on that in a moment. What I will say to all of you future grad students and things, finish your PhD before taking the job. Don't try and do both at the same time. It is a terrible, terrible thing to do to yourself. At least be in a good stages of writing. It doesn't have to be fully defended and everything, but you don't want to be like trying to finish doing research conclusions while starting a job. That's not good. Starting or working actively on another job. So that was if I could go back to Ryan in 2009, the idea that I'm gonna work part-time, finish the PhD. So my journey in the private sector, it was a great fit because I got to program and apply my radar expertise. It was a natural fit there of being able to do radar, doing the programming, lots of playing with data visualization and 3D graphics in that program, lots of dealing with radar algorithms and daily problem solving. The ups of that was my first real world job. So having to work with a team, not lone grad students sitting on my computer in the corner just doing my thing, but actually needing to coordinate with people and interact, and having to deliver things, not just every now and then a conference presentation, but actually a customer paid for this feature, we needed to get it out. I learned Git while I was there, and also recovering from one of my monumental screw ups was there was a day doing Git, and I force pushed, thinking I was force pushing to my branch. I force pushed over the master branch on the company server for Git. And so I had to send an email to just a few of the coworkers who worked on that server and said, don't push anything else up because I have to go fix this. And thankfully, that's when Stack Overflow exists. And I'm sitting there on Stack Overflow learning about the internals of Git and how do you recover if you screwed this up. And I learned all about the Git ref log and things like that, and logged in, got it all back. I mean, it wasn't like I deleted the entire thing, but there's a certain embarrassment you feel when you lose other people their work, even if it was just a few hours. It's like, nope, I got to fix this. And I did, but messed up and learned enough to recover. I will never forget that feeling of oh God, what did I just do? How do we minimize this? Okay, I got to send this email and so forth. But that was a moment, let me tell you. The downs of my experience in the private sector. Being highly customer focused, and that means the customer is always right kind of thing. And for me, that's not something I'm good at. And companies need to make money, and that means making certain decisions that you may not like. It's just a different market from being an academic and being open source software driven and things like that. It just wasn't, it ended up not being my kind of thing. And being responsible for code running, I'd start taking responsibility for our signal processor on the radar. And so being responsible for the signal processing code running on radars around the world and needing to debug when those things aren't working properly, that was taxing. It was great responsibility. It was kind of cool doing that. But when, the rubber met the road of, I've got to figure out what's going wrong here on a radar running in Korea, that was kind of like hitting the limits. And as of 2013, I had still not finished my PhD. That's 4 years after part-time finishing. So at that point, Unidata came around and had a friend, one of those grad school colleagues, reached out and say, hey, we're going to have an opening. Would you ever consider that? And I think he got me on a particularly bad afternoon where it wasn't just yes, but it was, when are you posting it? Yes, 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 yes. And so went through that and got hired to work on the Threads project, which are written in Java. Didn't know Java. Up to that point, never had I done anything in Java. They weren't actually looking for any, that wasn't a hard requirement. Because I had done enough other things, I knew I knew weather data, experience in the field, I had enough programming experience and just general things related. They're willing to hire me knowing I didn't know Java, learn Java on the job, but that meteorological expertise and an interest in programming, that's a pretty sweet spot. And having people who know that stuff and have the capacity to learn, and then demonstrated once you know one programming language, I'm not saying it's you automatically got to step in and can do all of them right away, but the concepts, the abstract thinking, loops, ifs, things like that, knowing that, the rest is just syntax. The rest is just learning how to spell it differently. Generally, there are, some languages are good at different things, and Java happens to be close enough to C++ that it wasn't a stretch for me. The one scary part about that was I finally had to leave my bubble in Norman, Oklahoma. So I had come to college in '99, and I hadn't had to leave, grad school, a job, all of it. I got to stay in Norman. So after 15 years in Norman, I finally had to say goodbye and take my job. But there, I finally got to defend my PhD in the fall of 2014 and graduate. And that definitely felt like Frodo throwing that ring in the volcano, like way down, and finally it's gone. At that point, it was probably more about getting through and not wasting years of effort. I'm not going to say PhD hasn't served me at all. I think it has its moments, but I didn't get hired because of my PhD, and it is not necessary for 99% of what I do on a daily basis. So again, I'm glad I finished it. I'm glad I got through and finished what I started. But if I had hindsight and could say this is what it's going to be used for, I might not have done it. Even now, it's still not clear, but I also wouldn't want to do it again either. So like it was a PhD is a thing. Not to scare anyone off. It's just what I always say is there'll be a moment you're doing a PhD and you're going to be like, I don't want to do this anymore. I'm tired. I just want to quit. And you have to have some reason that gets you through that moment. And man, I think that moment was more my wife being ready to kill me than anything else if I had quit. So not the best reason to get through. So Unidata is really the first job I've had where I've completely bought into the mission. Like it is just the community focused, they're doing open source software. I get to work on code that everyone gets to use for free and support a community I care about, the meteorology academic community. And so that mission really makes it compared to where I was before, where I wasn't bought into the commercial radar mission, doing things for people I don't have, I can't relate to necessarily, just wasn't nearly as rewarding as working in the open source and working to serve the academic community. I mean, this is every programming job, but really Unidata, every day is different. There's a new problem. There's some weird challenge, some weird data thing cropped up. Weather Service is constantly putting new data out there and figuring out why that's breaking things is some days it's a fun challenge. Some days it's a frustrating one when you just want stuff to work. Or when you have 10 of these challenges already backed up and you don't need an 11th. So the good is I get to play with weather data. The bad is I have to solve issues involving our infuriating data formats and their questionable documentation that the Weather Service puts out there. And so a lot of days just end up being this. I have never actually broken a computer, but there are days where it's just like, why won't you work? Why can't you? Why? Never goes away. And then the other thing is, what else do I get to do at my job? Well, I write proposals, I supervise students, I teach, and I go to meetings. And so if you remember what that list looked like of watching what the other faculty did, now, I still get to code. I do get to get my hands dirty, not as often some days as I want, and the proposals are a necessary thing, and they're not science proposals, and really it's just summer interns I'm supervising, and I'm only teaching workshops, not full semester courses. So it's not all equal, but I just love the things I called out in my head, like, I don't want to do that, and that. Well, guess what? Still doing some of those. Now, I do love teaching the workshops because I get to drop in for a couple days and teach and then get my fill and get out. And then Unidata, really, we're wearing all the hats. It's not just developer. We're quality assurance. We're our own people making sure the code's doing what it should. We're developer relations who are reaching out to the community and helping you all use our tools. We're the technical support answering the questions, and we're project managers. And so it's not this where you think, or at least if you've ever witnessed what the broader software industry looks like, where you have all these different people and these are titles that people have as their individual jobs. And nope, we are all of those here at Unidata, which also helps keep things mixed up. You know, one day you're answering questions, another day you're making releases, another day you're teaching workshops. So it keeps things interesting. And just a brief go over some of the cool things I've gotten to do. So being able to help keep or get Nextrad data up on Amazon S3 so that the entire Nextrad archive and continually adding to it in real time is available to the community on Amazon. That was a really cool project to do that from scratch. Getting to work with the GOES 16 data when it started coming down the pipe and help get those images out to the community. Getting to bring MetPy back from the dead in 2015 was nice to be able to do. I like solving puzzles, so writing Python code to talk to some new data access protocol, that's fun because it's just a puzzle challenge. And then really every workshop I've ever taught has been the fun. It's great to come out to you all or other schools and get to teach a workshop and get feedback and see how we're making things work and how we're not. And to be able to have hands-on experience with how to fix that is really, really cool. So get to the end here. Just a few lessons I wanted to make sure I called out that I've taken away from this path through software and where I've ended up here. And the things that, you know, if you want to get into this, you know, to take away. And the first one, you see a lot of it on Twitter, at least, imposter syndrome. It's real. I can honestly say when it comes to programming, I've never felt it, but that's probably a mix of arrogance and hubris that we've talked about. But I don't want to hold anyone else back. There's no such thing as a real programmer, or maybe really it's conversely, there's no such thing as a fake programmer. If you write some code, you're a programmer. And the only thing that makes some better than others is you try to get better at it. And the first code you write, it's just like the first draft of an essay, of a paper. It's rough, and you go back and refine it, and it gets better, and you learn to be a better writer as you get feedback, and you keep doing that. No one starts off writing great code. If I go back to my grad school code, if I go back to early MetPy code, if I go back to MetPy code I wrote a year ago, every one of those I'm like, what were you thinking? What drove this? How did you get this? So you got to start somewhere, and the internet, as I kind of mentioned, you have got untold amount of resources there and Stack Overflow, but also just more general put together resources. You know, Stack Overflow is great for asking questions or seeing answers to questions, but you've got a lot of just great examples out there of how to go and good resources like, you know, if you're getting into Python, Unidata, to help you out and get you on the good path. Embracing failure. I fail in some way every single day. Either, you know, oh, the code didn't work how I wanted it to. Oh, I found some bug in something I wrote. Pushing to the company Git server and blowing away somebody else's work. You know, I know Git really, really well because of that day. I know the intricacies of Python because of every bug I've had to understand why my code's not behaving like I thought it would. You know, better if you can, while you're doing, you know, embracing failure, do it with a net, you know, try to avoid the situations where you blow away code on the company Git server, but otherwise, you know, accept the fact mistakes are going to happen and just roll with it. And really, if you want to pick up these skills, you just got to do it. There's no, too many times I've tried to pick up computing skills by, oh, I'm just going to read all these things from first principles and then be able to just magically do it. And that's not how it works. You got to have a project that motivates you to get through the hard parts, and then, you know, that you want to build up a piece here and a piece there. You need this corner. You want to figure out how to make this part of the plot this color, and go now just learn that little bit of matplotlib syntax. Or you want to go read this new data format. What functions can I call to read it? And honestly, don't worry about, if you want to be getting the programming and whatnot, having some kind of formal training. Literally nothing I do on a daily basis was part of my school curriculum. I've taken one computer science class, and that was a Fortran 90 course. The last time I touched Fortran 90 was literally that dumb website thing I had displaying the obs for the temperature for the forecast city. Otherwise, everything I've been using has been, you know, self-taught. Now, I think we're in a good shape in the meteorology community teaching Python and helping you all get good skills, but just don't feel like you have to have it in a class to somehow use it or be able to claim it. The best things are the project you've worked on and the code you've written and, putting it up on your GitHub or whatever else, just that you do it and make your maps and make whatever cool projects you want to get going. And stick with it. Like the biggest thing, that I probably have in addition to the hubris to think I can do something is that feeling of, so help me God, I am going to make this work. And until it works, you are going to bend to my will, you stupid computer. And eventually get there. And like, not working is the most incredibly frustrating feeling. But when you get that win, when it gets all of a sudden the image you wanted pops out, or after an afternoon of wondering why this won't work, and you suddenly have the aha moment, man, that endorphin hit is addictive and usually comes with a good lesson that you can apply going forward out of it. And then the last thing, it really came from reflecting on this, is having a job that, you like, the mission fits, and follow your passions, kind of the trite way it gets sold a lot. And that's really not necessarily the great way to put it, but find the place you want to go where the values of the place, the mission they're working on, help motivate you. And that could be, that private sector somewhere. That doesn't have to be community service. That can be your own research program as a PhD, or that could be working a lab somewhere. Just having the mission that you actually care about really helps, makes it easier to get up in the morning. And with that, I thank you all for listening to me ramble on for an hour, and I am happy to take any and all questions you all have.
Awesome. So yeah, we'll give it open up to questions here. So if there's anybody on the call that wants or has a question, either you can throw it in the chat or unmute yourself. Or if there's anybody here too, we can open it to them. But as I figure out the camera again, here we go. But thank you for the presentation, Ryan. That was definitely very relatable. I think even for the freshmen, as a lot of them are going through Kevin's weather technology class, working with Python. So I think they can definitely relate to you on that. But are there any questions right now?
What would you say is the most rewarding part of your job?
Right now, the most rewarding part is seeing the payoff for all of you getting something working. And that can be answering a question where I was struggling with this and I just can't figure out how to get this to work, and pointing someone in the right direction. Oh yes, that's it. That works great. Thank you. Or seeing some feature crop in that people are using into MetPy, that people are using in publications and whatnot. Seeing something you built get used, or being able to help someone's not have to struggle with these same problems is really what I like. That's the most rewarding. I mean, the endorphin hit is also just solving the problems. My friend Sean, who I work with, helped me get the job here, always joked, in grad school, I'll do programming challenges like other people do Sudoku. So there's the problem solving element I enjoy, but really the rewarding part, the part that, where you feel like you're making a difference is helping the payoff for all of you using stuff and getting what you want to get done.
I just remember I took Meteorology 330, so it's a computer application course, also with Kevin, and just when like the big red error box pops up, and it's just like, oh my gosh, what did I do? But then like when Kevin comes over and he sees the red box, but then he explains like actually what's wrong with it, and then it clicks, and then it's like, okay.
It's a great feeling.
It's a great feeling.
So maybe a question for you, Ryan. I know some of this came out in various ways throughout the talk, but a lot of these students, they're freshmen, sophomores, juniors, and seniors. you know, if there's one thing that you wish you knew back when you were an undergraduate about life in general, about working within this field, kind of what have you, you know, what's that one thing that just like could have made a difference, not necessarily in choices that you made later, but just something that just really would have been helpful to hear at that moment, that then would have, you know, is something you know now that would have been helpful then.
I think, and this one's probably a lesson that's honestly been learned probably in the last 5 years. I think there was always waiting for a time where it seemed like all the others above you had it figured out. And, you know, it was always waiting, going through undergrad, fine. Okay, grad school is when obviously you get it all figured out. Okay, or maybe or master's, PhD. We're all constantly trying to figure it out. I mean, I've just given up the idea that somehow going to figure out. Now, does that mean I have gotten more comfortable with my place in the world and in the field over time? But, you know, as we've gone from being the kids in the field to the old farts in the room, or at least the mid-career farts in the room, it's like that feeling hasn't changed. It's always like, don't have it all figured out. Feel more confident in my ability to get some answers if I need it, or figure it out at some point when I have need, when the need arises to figure something out. But ever feeling like, you know, oh yeah, someone's going to come and deem you, okay, you are now a real meteorologist, or you are now a full air, like, doesn't happen. It just, everyone's always struggling with those same feelings.
Yep, I think a good way to sum it up might be, we can fake it better now.
Yes.
So what, you kind of talked about this a little bit in your presentation, but what would be some advice you would give to somebody that wants to become more familiar with Python, or just computing programs in general? I don't know, like sitting down and actually like using it is a good way to do that. But are there any like specific projects that you would try to focus on, or anything kind of like that?
Sure. So I think, yeah, it is do it. And, you know, we have our Unidata Python training resources, which if you just Google that phrase, Unidata Python training, you'll get to our site. And that's a place with some examples. But if you really want to get comfortable, the doing it part is, it's making something you want to see. Now, it could be a duplicate of a map that you like that some other site already does. It doesn't have to be completely original things. Like, pretty much for the most part, every synoptic visualization that's out there has already been done, you know, here and there. And then you can get a master's or a PhD if you come up with something new, but otherwise it doesn't have to be completely new. Seeing something College of DuPage has that you just want to figure out because you can, or answer the question, can I do this myself, are perfectly good reasons. I mean, half the GEMPAC maps I made in undergrad were knockoffs of things other students had on their own departmental websites. And it's just something, the inquisitiveness, the, can I do this? How do I do this? What's it take to make this work? Because then once you have your knockoff, you can figure out how to customize it, or you can plot other fields, or you can, you know, it's that first one, that first project is the hardest. And I understand the challenge of the blank page, which is why it's nice if you can start with other code that's out there. So, you know, there's a certain value in having the notebooks that we have out there with all the Python code. At some point, I think there's also value in starting from scratch, just so you build it all up and you understand. Because when you run a notebook, you try to go through it every line and understand what's there. You don't. But man, if you build something from scratch, you know very intimately what lines are necessary for something to work. Because without this line, something doesn't happen. Without this line, CartaPy screws up my plot and things aren't where they should be. Without this line, matplotlib decides to do its own coloring and not the colors I want. Things like that. So it's, I'd say, just something you like. I mean, if you want to get going, figure out something you like that you want to make appear your own version of in the world. It doesn't have to be weather maps either. It could be looking at some satellite data, or it could be making some SQTs, or calculating something. I mean, if in meteorology, I feel like we get the payoff, which is, I always try to get there when teaching, the payoff from the visualizations, the plots. So I try to get there. If you can just run a program and get a number out and be happy like that, you know, calculating something, some number, calculating CAPE, then, you know, by all means, whatever fascinates you and whatever thing you like to see, I think that's where you go.
Awesome. Thank you. I don't want to finish. Thank you.
Do you have one moment in particular since working at Unidata that like sticks out to you, or just kind of reaffirm like I'm where I'm supposed to be?
What was that last part?
Oh, just like one moment that kind of like reaffirmed this is where I'm supposed to be. Like,
oh, this is where I'm supposed to be. I mean, I'll say from the start, when I wrote my cover letter, I kind of knew that this was a place that was going to work out really well, just because like I got to write about how passionate I was about open source and doing things for the community. So that already like, I knew that was going to be a good fit. But when I got there, that confirmed all that. It's hard to say one that stands out because really there are so many that fit. You know, programming, you know, it's getting to play with help threads, the thread server, which was what I initially worked on, getting to, you know, help clean up the radar data support in there, and you know, get that working, and you know, help people get to that. Or actually, probably, you know, the putting together that whole thing that does the real time Nextthread archive and doing all that data work sticks out.
it's a loaded question, I know.
Oh, it's a great question. I mean, I can think of all these great ones where, you know, the day MetPy went from basically it started, I'll say Skunkworks, where it was, I'm just going to start working on it and realizing no one's going to tell me no. And it was something the community needed, to getting to the point where get told, okay, you can work on Python full time and we'll hire someone else, and starting our Python, well, maybe not starting, but formalizing and getting to the point where we had a formal Python team at Unidata. That's probably the pinnacle. But also every time we go to AMS and we're getting to talk with you all at the student career fair and talk about the student internship program. We're closed now, but be on the lookout next fall, winter, for the Unidata summer internship program. Come spend a summer working with us at Unidata on our cool tools. Getting to talk with you all at the student career fair or at our booth at AMS is always so, like, just those conversations mean so much more to me than I did when I was at a booth at AMS at the last job, and those conversations, other than when Kevin would come by anyways, weren't the same. And so it feels more natural here. And so which is why this AMS just killed me, because we didn't get to do that nearly as well. I'm hoping, really hoping for Houston. But yeah, those are some of the moments that really stick out, is like, this is the place. And it's not like every day is like sunshine and rainbows. The days where I have, 6 hours of meetings in a day, or, I mean, honestly, some days the questions grate on you a little bit. Granted, it's sometimes because the questions, you don't feel like some people put any thought into what they're asking you and things like that, and, or the days you're just dealing with another darn data feed problem. Like, sometimes those are fun, sometimes they're awful. So, not every day is great, but I already knew this. I'd established a lot of this in grad school, because I came up with the phrase I always put it as is, the worst day coding is better than the best day doing anything else, at least for me. And so I kind of knew the programming side of things. The worst day working on MetPy itself is better than the best day doing Darty or anything else. And that even includes writing proposals. But that's how I know, it's like when I'm doing some things that are not core, but I still see the value in them, that's probably what really helps. So going back to that last bullet about mission and values, like I see this as important. This is important to me. This is important in the broader picture. And so I'm feeling less terrible about spending my time on it. Conversely, when I don't see the value in things, that means going to a certain meeting can be just soul sucking. Luckily, the overwhelming balance is on the plus side and not the minus side. And that's, again, how I know I've found the right spot.
Are there any other questions from in the room or on call? I'll leave it to for a little bit. Well, I do have one last question for you. You already kind of talked about it. I'll come around this way. I don't know if you can see me. There we go. Okay. You mentioned the internship that you guys have at Unidata. So what would be some advice that you give for anybody that's interested in applying for either that specific internship or just for internships in general, given that it's a vital part of being a meteorologist and kind of making those connections with other professionals?
Sure. So in terms of applying, I think I could only really speak to ours because we have a unique slant since we're so software focused. So on the getting in, really that one's about on our application process, and we're working on improving our selection process and helping these steps, but it's about having used our stuff, something. I mean, I obviously work on MetPy, so that's my baby, but any of it, having a familiarity with the Unidata tools. You don't have to be an expert user. You don't have to be an expert coder, but having used it and being able to articulate in a cover letter why you're so interested, why coming and spending 11 weeks with us in Boulder and working on this, not doing science, because we don't do science. We work on tools and support the community. So why spending your summer work on these tools would be so fun, more or less. Why it excites you and why that's going to help you in your journey, in your career. That's what we're looking for. And we're trying to help people, help students gain experience and skills and on the technical side of things, on the tools side, the software side, computing, than necessarily science acumen and experience doing research. And that's not just, I mean, that's to your all's benefit, and that's helping build the workforce. Honestly, we also hired our first former intern this year. So it also helps us have a good pool of people who know us and have worked with us in the past. And so that's our goal. So that's the applying. In general, with internships, it's take advantage of the opportunities that come your way there. And it's not just the day-to-day work and who you're working with, but like you mentioned, growing that network and networking with people. So, it's at least at the NCAR affiliated ones, or UCAR, that's us, but it's also SOARS and SciParks, and I think those are the major ones, but there's a lot of other smaller programs going around. So, in any organization, if you're going to the Oklahoma REU or the Hollings Scholars or whatever, just, they'll run a variety of things to help you with skills or networking or whatnot, and take advantage of those opportunities. And, I guess it also goes back to the overwhelming amount of people in our field are exceedingly friendly and really want to pay back what we've gotten in the past from others. I did a lot working on my own in the corner, but when I had questions, when I needed support from people, I had many people helping me along the way on this journey. And so speaking for myself, I'm very much keen to help pay that forward and answer questions and help give advice and whatever else I can, and have conversations. And so I guess when you're doing these internships, don't be afraid to have the conversations with this person or that person who you have questions for, or, or need some help from, or whatever. Don't, I mean, we're all just people. And I know certainly going through, my experiences, I never actually did the internship. I just got my student job, but I certainly made the most of that opportunity in what I had there. And then I'm glad I had the people supporting me there and was able to ask my questions without getting stomped on or anything. And was also, yeah, I guess grateful for those opportunities.
Awesome. Well, thank you very much. I'll leave it open again for a couple seconds here. If there's any last minute questions, or if there's anything else that you wanted to mention, Ryan, before we hop off.
No, I'm happy to take, if anyone thinks of anything. I didn't put my email in the slide. It's rmay@ucar.edu. Happy to take other questions if you think of anything, give advice. And then just, yeah, Unidata stuff's free here for you to use, and we're happy to help you all use it. So that goes for Python, but that goes for AWIPS, IDV, NetCDF. Here to make your life easier. And then I guess take with you, Unidata's here, and that's not just now, but that's for your careers in the industry. And so, when you think of, we want to be synonymous with you're all using data, and think of us. And if there's something we're not doing, we want to know about that too. And just there are ways to get involved in the future with Unidata too, both as students on our users committee, or wherever your careers may take you as faculty, or just using our stuff and asking us questions.
Well, thank you again. I wanted to commend you for kind of tackling our theme of this series, which is kind of looking at your past and reflecting on everything, the challenges and the successes. So that definitely hits home with a lot of people, and I appreciate your honesty in your presentation today. And I'll make sure to go ahead and share your contact info with people so they can reach out to you if they have any more questions about Unidata or Oklahoma, or just stuff in general.
Absolutely.
Yep. But yeah, thank you again.
Thank you all.
Go ahead and. Okay. Oh yeah, stop.